This video is part 3 of a 3-part series and will discuss the Node-RED project code that was used to develop the LotBot Jr prototype. The code may not mean much to you unless you saw the introductory video on my LotBot Robotics channel named LotBot Jr and ESP32 Raspberry Pi Node-RED MQTT Wi-Fi access point development project. In order for this video to be of benefit to you, you probably already installed Node-RED and have some idea on how to connect nodes together. Also, there are Node-RED instructions on how to create a node on the internet. Looking at the main project Node-RED flow, you will see the nodes I created in pink. The second node in the flow is wireless mini keyboard data and is used to receive commands from a wireless keyboard that has a companion USB dongle plugged into the Raspberry Pi, as was shown in the introductory video. The data it receives is passed to the third node, 1 in, 3 out. I had to create 3 files for each node and will discuss them in detail. First, I need to say that when these 3 files are built and linked into the Node-RED library that defaults to .node-red, the nodes are added to the node sidebar list on the left of the display. Since my nodes are built as LotBot entries, I need to scroll down the nodes to the LotBot nodes for you to see them. Placing the cursor over the 1 in, 3 out node displays the node description that I set up in one of the files. The node takes in 1 input and decides which of 3 outputs it should be sent. Placing the cursor over the wireless mini keyboard data node shows a description of what it does. However, this node is more complex than the other node as it interfaces to a Python script. So I am going to discuss the simpler 1 in, 3 out node first. When we go into a terminal session for the Raspbian operating system on a Raspberry Pi, we are in the Pi directory. I created a directory, LotBot Jr Node-RED nodes, to contain the node directories for each of my nodes that I created for this project. In the 1 in, 3 out directory are 3 files required for the 1 in, 3 out Node-RED node. The files are an HTML file, the 1 in, 3 out .html, a JavaScript file called 1 in, 3 out .js, and a package.json file. The best place to understand how to create these files is in the Node-RED documentation. However, I will be telling you what entries I use to create my files. The package.json file is required to identify the Node-RED node. It is easily created by using the command npm init --yes. This output is the file that is created. The properties from name to license are generated for you. The name property is automatically picked up from the directory name. So I make the directory to contain the node files the same name as the Node-RED node. The main property also uses the directory name plus the .js to identify the JavaScript file that contains the logic for the node. I added the description I wanted for the node. I did not touch the version, scripts, or license generated property defaults. I added the Node-RED lines after the license property and added a Node-RED entry for the property named keywords. The Node-RED entry identifies the node in this package, which is just the one node, 1 in, 3 out. You may want to get deeper into the properties than I did, but what I did was sufficient to get the node to work. The 1 in, 3 out.html file is created as discussed in the Node-RED documentation, and are the definition of the node views that appear in the Node-RED editor. The HTML script tag identifies the JavaScript entry that registers the 1-in, 3-out node with the editor. I created a new entry on the sidebar for my project nodes called LotBot by entering the word LotBot as the category. I use the RGB color code for pink. I don't have any parameters to edit in the edit dialog that I needed, so I left the default empty. The node has one input from the upstream flows and sends it to the flows downstream. It picks one of the three possible outputs. I changed the icon to a function icon instead of the file icon that I had in the intro video, even though I grouped it as a LotBot category. The Node-RED documentation says that the label is a function that returns the name or something meaningful, so I return the node name. However, I don't use the function, and at this time I am not sure what to do with the entry, but it seems to be necessary for the node to work. The second part of the HTML file is for the parameters that are in the edit dialog, and since I don't currently need any, I have left that part out of the HTML file. The third part is the node help text that is displayed when the cursor is put over the node in the sidebar, as I showed you earlier. The help is also displayed in the info window when the node is selected. The 1-in, 3-out.js file contains the logic that is to be performed when the node is next in the flow. The documentation says that the first line provides the node access to the runtime API for Node-RED. The function 1-in, 3-out node is called including parameters from the flow editor, but for this node there are no parameters. The this variable refers to the instance of the node that is executing. The node will send a message to one of three outputs and will send null to the other two. Message null, that variable, will be used for the null messages. When an input message is received, the this_on input message is processed by this function. If the message data, called a payload, is a 0 or 1, the message is sent to output 1. If the payload is a F, B, L, R, or S, the message will be sent to output 2. These two outputs were demoed in the intro video. If the payload is any other character, it is sent to output 3. That is the logic of the node. The last line in the JavaScript file sets up the function to be used for the node. After you create these three node files, you need to run sudo npm link in the node directory and npm link with the name of the node in the .node-red directory to generate the nodes. It's a good idea to stop and restart the node-red process to see the generated node in the node-red sidebar. I had modified my environment to not create the package.json file in the node directory. I really like Node-RED as a way of developing connected projects. For example, I set up another flow to show how the 1-in, 3-out node can be tested without the wireless mini keyboard data supplying messages. I set up a flow that has 5 inject nodes to test the 1-in, 3-out node as in the intro video using the wireless keyboard. Using these inject nodes, you can turn the LED on or off, and F or a B MQTT message can be sent, or an invalid message like the time can be sent to test the 1 in, 3 out node's logic. Now I want to start talking about the more complex wireless mini keyboard data node. This node has its own HTML file, JavaScript file, and package.json file. There is also a Python file for this node. I could not get any of the available USB-like node-RED nodes to interface with the wireless mini keyboard dongle. I also could not get the JavaScript to interface with the dongle. So I wrote a Python routine and called it from the node's JavaScript code. I had the Python code already working in the larger LotBot project, so making it a callable routine was very simple. I will discuss the Python code after I discuss the 3 files for the wireless mini keyboard data node. The package.json file is generated for the wireless mini keyboard data node the same way we generated it for the 1 in, 3 out node using the npm init --yes. The only changes I made that differ in this JSON file is the wireless mini keyboard data node's name that is taken from the directory name, and the node description was also changed. I also set the author to my YouTube channel name, LotBot Robotics. The wireless mini keyboard data.html is the same as the 1 in, 3 out HTML except for the register type and the function return. Both use the node name. The help text has also been changed, of course, because the wireless mini keyboard data node does a different process. The wireless mini keyboard data node logic is contained in the JavaScript file. The first few lines are the same as in the 1 in, 3 out node, but the function logic is very different. The node on input function sets up a variable myPythonScript path to hold the name of the Python code wireless mini keyboard data.py. The code uses the Python shell library to interface to Python. A new instance of the Python code is set up. The pyshell.on will process each message it receives from the Python code's output. This message is set up as a payload and sent downstream in the flow. In my logic, that would be sent to the 1 in, 3 out node. The last line of the JavaScript file sets up the function to be used for the node. This is the Python code that is called by the JavaScript code. Before I go through the logic, let me show you that the code is sending the messages that the wireless mini keyboard data node is expecting. Going to the Run icon, I select the Run module and an output display opens. Using the arrows and the other keys on the mini keyboard, I see the F, B, L, R, S, 0, 1, and some not supported selected keys displayed. So the Python code is producing the required message interface. Okay, now to look at the code. The EV-DEV library needs to be loaded from the internet. Then the code has a few imports of required libraries. The variable D is set up as an array to hold any mini keyboard devices found connected to the Raspberry Pi. Devices is set to the devices found connected to the Raspberry Pi. I go through the devices to find the mini keyboard devices and put them in the variable D. The code selects just the input devices and saves their descriptors. The code then grabs these devices to be only used by the Python code. If this is not done, then the keyboard could also be used as a standard input. Now set up a never-ending while loop. We check each mini keyboard input device, which in my case will only be one device, for an event being created by data being read. If the event.value is a 0, 1, I set the code to the event code. If you print the events, you will see that there are several events for a single key being pressed, such as the key being pressed and then the key being released, which will give you several events. I have commented out print to look at the code, but it is not a bad thing to put prints in throughout the code to see what's happening during development. You really need to know what codes are generated for the key you press. Using the mini keyboard that I am using, when I press a 1, 2, 3 up to 0, I get the codes that are 1 bigger. So when I have print statements, I see a 2, 3, 4 up to 11. So I set the messages going back to the node to the correct value. eCodes has a table of literals that can be used instead of numeric codes that are the same as my mini keyboard produces for arrows and OK buttons. I check for these literals for the F, B, L, R, and S. On the other hand, I get different results for the home key and for the info key from my mini keyboard than the literals that are in the eCodes. So my code will work with the literals or the codes that I'm getting back from the mini keyboard. The last line in the while loop sends back messages for other keys that are not supported. And that's really everything I've got to tell you. Well, I've been told that you learn more by trying to explain topics to others. I found that I learned a lot on this project, but even more putting this video together. I hope you all liked it as much as I have in making it.